Hey everyone, and welcome. So today we're going to dive into something that every single Salesforce developer runs into, debugging Lightning Web Components. You know, that feeling of hunting down a tricky bug. We're going to turn that whole process from frustrating into a real skill. Think of it as becoming a code detective. Let's jump right in. First things first, let's get something straight. Why do bugs even happen, right? Especially when you feel like you've done everything right. Well, here's the truth. Bugs are not a sign that you're a bad developer. They are an absolutely normal, inevitable part of creating anything cool or complex. So instead of seeing them as a failure, start thinking of yourself as a detective. Bugs aren't problems, they're clues. And make no mistake, the stakes for this detective work, they're huge. A single, tiny bug can completely break the user experience, it could lead to data loss, or it could even cause a whole deployment to fail, stopping everything in its tracks. But on the other side of that coin, every single bug you fix makes your work stronger. It leads to components people can rely on, users who are happy, and your whole team moving forward faster. So every good detective needs a kit full of tools, right? For us as LWC developers, our most important toolkit is already built right into our web browser. See, because Lightning Web Components run on the client side in the user's browser, that's exactly where our investigation has to start. And getting into this toolkit is ridiculously easy. Seriously, all you have to do is go to the Salesforce page where your component is, then just right-click anywhere on the page and hit Inspect. A new panel will pop up, and all you have to do is click on the Console tab. That's it. This console is basically your command center for figuring out what's going on. Now, inside that console, you've got three main tools. Think of console.log as your magnifying glass. It lets you peek inside your code and see the value of any variable at any time. Then you have console.warn. This is like finding a weird footprint at a crime scene. It's a clue that something isn't quite right. And finally, console.error. That's the smoking gun. It points you to the exact spot where everything went wrong. All right, tools are ready. Let's crack open our first case file. We're going to start with the most common thing you'll see, a plain old JavaScript error that's happening right there in the browser. And wow, this is such a classic example, a mistake we've all made. On the left, the code just assumes that the ACAC variable is going to have data in it. It tries to get the name property. But what if ACAC is undefined? Boom, the whole component crashes. The fix over on the right is so simple but so powerful. It's just a quick check. Hey, does ACAC actually exist? If it does, great, we'll use it. If not, no problem, no crash. That one little check makes all the difference. Okay, case file number 2. And this one's a little trickier. What do you do when the bug isn't in your JavaScript at all? What if it's coming from your Apex code on the Salesforce server? Now the clues are a little more hidden. Okay, so this right here, this single line of code is the absolute key. When an error comes back from Apex, it's not just a simple message, it's this big, complicated object. If you just do a console.log on the whole error, you're going to get a bunch of useless noise like object. But if you log error.body.message, that's the secret. That digs into the object and pulls out the one thing you actually need, the clear, easy-to-read error message from Apex that tells you exactly what went wrong. And this is a huge deal when you're using the @wire service to pull data from Salesforce. You have to remember a wire call can only end in one of two ways. It either works and you get data, or it fails and you get an error. There's no in between. So a really solid bulletproof component has to be ready for both. You need code to handle the happy path with data, and you absolutely need code to handle the error path. You can't just hope for the best. But you know, just squashing the bug, that's only half the job. A truly great developer thinks about the next step. How do we talk to our users when things go wrong? It's all about protecting them from the messy technical stuff and keeping the experience clean. I mean, look at this. You can never show this to a user, ever. Seeing something raw like object, or a giant wall of technical code, it's just confusing, it's intimidating, and it instantly makes them feel like the application is broken, and they can't trust it. So what's the alternative? Well, instead of that mess, we can catch that raw error behind the scenes and show the user something clean and helpful, like a toast notification. A simple, clear message like, unable to load data, please try again, tells them what they need to know in plain English. It turns a bad experience into a helpful, professional one. All right, so we've put on our detective hat, we've solved a couple of cases, but what if we could prevent the crime from happening in the first place? Let's talk about shifting from being a reactive detective to a proactive one by building better habits. Okay, so let's wrap this all up with the official detective's code. These are the rules to live by. First, the do's. Do use console logs to investigate, but always remember to remove them before you go to production. Do handle every single potential error from Apex and Wire, and do show clean, user-friendly messages when something goes wrong. Now the don'ts. Don't just ignore errors you see in the console. Don't leave your messy log files in production code, and, as we saw in our first case, never ever just assume that the data you're expecting is going to be there.
And that's a wrap. But before you go, I want to leave you with one final question to think about. Based on everything we just talked about, what is one potential bug, one single error that you can proactively go and prevent in your own code tomorrow? Thanks for tuning in.